Hey 8th graders, welcome to your last assignment / lab of the year. I'm excited to be making this last video of this crazy DLI COVID ridden year, and you guys should be excited to potentially be coming back to school next year and being able to do these kinds of things in person. But with that being said, let's go ahead and move through this lab. You guys will have 2 days to work on this lab. I wouldn't think it would take you more than 1 though. So obviously my kids in class, they have a little bit more of a cleanup, a little bit more of a setup than you guys have just watching a video. All right, so this is the Signs of a Chemical Reaction lab. Our last assignment that we did last week talked about the 5 different signs of a chemical reaction. So you guys will have a second to review those here. Those should also be in your OneNote. Your learning targets for today: I can identify if a chemical change has occurred. So again, you'll be using those 5 signs of a chemical reaction to do that. And I can use the law of conservation of matter to identify balanced and unbalanced equations. So you guys will be doing that on some of these stations. So these are 10 lab stations that you'll be working through 10 different chemical reactions. And you guys will identify how you know there's been a chemical change that occurred. Okay, so let's go ahead and take station 1, for example. You guys will see the directions that the kids in class go through and the directions basically that I go through in the videos. But the main thing that you guys will need to see at home is this little video down in the bottom right-hand corner. There will be one on every direction page for each of the 10 stations. So you'll right-click that and open it up. And I'll just show you one example of what these might look like. So this is the first one for station 1.
Station 1, and this reaction should look fairly familiar.
Okay, so that's what station 1's video looks like. You guys will obviously need to watch that in its entirety to get all of the observations out of the way. For each and every one of these 10 stations, you guys will need to write down your observations. Okay, so I'll go ahead and show you guys this first. This won't be on all of your stations, but it will be on some of your stations. Basically, you guys have 2 equations here. One is balanced and one is not. You guys will need to figure out which one is balanced and which one is not balanced, and you guys will circle the balanced one. So circle the correctly balanced equation. It's not necessarily the one with the coefficients. Sometimes equations are balanced with just one of every molecule that's in the equation. Okay, so make sure you guys go through. You guys can use your draw tool to kind of do a little count and say, all right, this side we had 2 sodiums, and then you can draw a line after the sodium, and that could be your reactants. This side I have 2. Okay, this side I have 1 hydrogen over here, and then 2 over here. Okay, so that right there should tell you guys that this first one probably isn't balanced, but double check the second one just to make sure. If it is in fact balanced, you guys will need to circle that. Okay, so again, that's not going to be on all of these stations because some of these reactions are a little bit more complicated and really hard to even just count to see whether or not they're balanced. So this is only some of them. Okay, and then the next slide we have for station 1, you guys will see observations. Again, you guys will be doing observations on every one of these 10 stations. Okay, you guys will also be doing this part on every one of the 10 stations. So these are your signs of a chemical reaction. Using your highlighter or your draw tool, you guys will circle all of these that you see happen. Some of these are really hard to tell if they're happening. For instance, energy change, if there's a change in temperature, that's hard for you guys to tell in a video. So make sure you guys listen and watch the video because I will tell you, this is getting kind of hot or maybe it's kind of cold, whatever the case may be. Okay, remember that when we're talking color change, we're not looking at a mixture of colors. Maybe we have a blue solution and a red solution and they make a purple solution. That's not necessarily a chemical change. So look for other signs of a chemical change there. Okay, however, if we have 2 clear solutions and they make like a rusty red solution, that's definitely a color change. Okay, so pay attention to what is just a mixture of colors and what's an actual change of colors. Okay, so color change, formation of a gas, you guys might see steam, you might see bubbles, however the case, you guys would see some kind of gas being produced. Okay, formation of a solid or a precipitate. Okay, remember it may not form like a solid block or a rock of something. It might be a powder, but that would still be a solid nonetheless. So make sure you guys pay attention to those videos because I'll kind of walk you through that formation of a solid or precipitate. Generally, you see that formation of a solid or a precipitate forming from 2 liquids. Okay, finally, change in energy. You guys will see maybe heat, light, any of those things. You guys might see different levels of light. So one thing I talked about with my kids that you guys will have questions to answer on is light has all kinds of different energy. So if you guys are walking by neon signs and they all have different colors that those neon lights are showing, okay, that's an indication that each of those burns at a different energy. Okay, so when we add electricity to those and they emit that color is based on the amount of energy that they emit in return. Okay, so if we are looking at a rainbow, the rainbow is our visible light spectrum. Okay, those on the red side of that rainbow are the lower energy. Those on the purple or bluish violet side are the higher energy lights. Okay, so if we're burning something and we see, so for instance, if you guys have a campfire, you light a match, it usually burns a yellowish orangish color. Versus if you guys have like maybe natural gas burners in your house, or even the burner that I use, the Bunsen burner in these demos, especially 4 and 5, those burn more of a bluish purple. A blowtorch kind of burns that white ultraviolet color. Okay, if we're comparing the energies of those, that match that you light or the campfire that's kind of yellowish orange are a lot lower energy than the other end of our like natural gases, propane, stuff like that, that burns kind of a blue color. Okay, so those would be the higher ends on those natural gas sides. They emit a little bit more energy when they burn. Okay, and then finally, you guys, for most of these, will have some kind of question to answer. This is a great one that I want to go through with you guys because it talks about the gas being formed in this reaction. If you guys just watch the video, you're probably not going to have any clue what gas is being formed. You might see bubbles being produced or some kind of steam or smoke, but you're not necessarily going to know what that is unless you guys look at the chemical equation. So as I went through in an earlier lesson with chemical equations, is you guys have these little indicators of states of matter written after every one of these molecules. Okay, these two reactions are both the same. So on this one, when I'm talking about what the gas being produced is, okay, we have sodium bicarbonate, which is baking soda, and calcium chloride are reacting to form salt. Notice that the salt is a solid. Okay, that is kind of a chunk that's left over in there. Water is a liquid, so that's the liquid that's left over in there. Carbon dioxide, notice the G after that, that's a gas. And calcium carbonate, which is also a solid that's left over in there. Okay, so when I ask you in the question, what is the gas formed in this reaction? Look at your products. Look at those states of matter that you see. Solid, liquid, solid. Oh, there's my gas. So what's my gas produced in this? This is CO2, or what we know as carbon dioxide. So you guys could either write the formula CO2 or you could write carbon dioxide. Okay, so make sure you guys, when I ask you guys maybe what the solid or the gas that's formed in this, make sure you guys look back at your equation, look at the products, and then look at those states of matter to answer the question. All right, so that's kind of what most stations look like. The two constants you guys will have is you'll have a video to watch for every one of these stations. Okay, you guys will also have observations to make, and you guys will need to highlight the signs of a chemical reaction. Okay, you may or may not have a question. You guys may or may not have equations to balance or to look to see which ones are balanced. Okay, so again, there's 10 stations. I'll just briefly go through those. So the first station, you guys have kind of already done this. The only difference is we're using a universal indicator, whereas before we used phenyl red. So that was where we used the little white pellets and the baking soda, and we added the indicator and mixed them in the baggie. Okay, on station 2, you guys are looking at copper sulfate, which is a blue solution, and adding a piece of magnesium ribbon. Magnesium is actually capital M lowercase g, but I picked a horrible font. Okay, and seeing what happens. Station 3, you guys are doing ammonia, which is the solution you guys would see in Windex. It's kind of got that stinky smell, but it's also found a lot of cat pee. So if you guys smell cat pee, it's that stinky kind of almost sharp smelling chemical in cat pee is ammonia. Okay, so you're mixing ammonia and then adding drops of copper sulfate, which is again that blue solution, to it to see what happens. Okay, station 4. Piece of magnesium metal burning. Remember, anytime you burn something, you need oxygen, so it's burning in the presence of oxygen. So those are our two reactants, magnesium and oxygen. And you guys get the opportunity to look directly at that, whereas my kids in class can't look directly at it because it could hurt their eyes. Okay, Then you guys have some questions to answer with that one, talking about that energy that I just went over with you guys. Station 5, you guys are taking a wood splint that has been soaked in strontium chloride, and you guys are burning that as well and seeing what happens with it. Station 6, you guys have a piece of chicken liver that you're adding hydrogen peroxide to. Hydrogen peroxide is that stuff that maybe some of you guys have in your household. It's in the brown bottle, and when you got a scrape or you get scrapes, you dump that on there and it turns white and kind of bubbles and it stings really bad and you blow on it. That's what hydrogen peroxide is. So you guys will see what happens when we add that to chicken liver. Station 7, you guys will be doing elephant toothpaste, which is one of my favorite experiments I do all year. Station 8, you guys are doing a little mini lava lamp using Alka-Seltzer, vegetable oil, water, and food coloring. Station 9, you guys are doing what I call the carbon snake. So this one's kind of a longer video because it does take a little bit of time for the reaction to take place, but overall it's pretty cool, pretty fun. And finally, Station 10 is my ultimate favorite. This is one I just do as a demonstration for the kids in class, but I like to call it the Hindenburg, where I am making explosive gas in a balloon and then we get to explode it. Okay, so those are your 10 lab stations. When you guys get done, go ahead and hand that in. I hope you guys enjoy this last assignment of the year. It's been great being your teacher, and hopefully I'll talk to you soon. Bye.